Let's look at the solutions for Chapter 9, practice problems numbers 2 and 3. I did these together because you can see that these two problems are very close. There's only one difference. In number 2, we have 10 framed photos and would like to put 6 of them on a decorative shelf. And then we want to know how many different ways you can arrange 6 of the 10 photos across the shelf where order matters. So the placement of it actually matters, whereas in number 3, the order does not matter. So when you have a problem where order matters, then you're going to find a permutation. Okay, so we have 10 items, we're going to select 6. And then the formula for finding a permutation is going to be 10 factorial, or the first number factorial, all over the first minus the second in parentheses factorial. So 10 factorial over 4 factorial. Now I'm going to write, and actually simplifying this, I'm going to have 10 times 9 all the way down to times 1. In the denominator, I have 4 factorial, so I only wrote this out until I got to the 4 factorial because I can cancel those two values out and I'm left with 10 times 9 times 8 times 7 times 6 times 5, which is 151,200 ways. Notice that there are more ways where the order matters than when it doesn't matter, and that should make sense, right? Because if you have them all just kind of stacked up on the shelf, you move it around, well, you're going to have less possibilities if the order does not matter. So the combination of 10 choose 6 is going to be 10 factorial all over 6 factorial. So we have an extra piece here, the 6 factorial versus the first one that was just 10 minus 6 factorial. So we have that here, but we have this additional 6 factorial. We have to divide by that to get rid of all those extra ways. Okay, so when I do that, again, I just kind of list the 10 factorial all the way until I get to 6 factorial, because here's a 6 factorial that I can cancel out with the other 6 factorial. And then I'm just left with the 4 times 3 times 2 times 1. I can do a little bit of simplification here. Notice that I have the 10, then I cancel out the 3 with the 9 to get a 3, and then I have a 2 and a 4 here in the denominator that cancel out with the 8, so I'm left with a 7. Again, you could just plug and chug this in a calculator if you wanted to, but in any case, you're going to end up with 10 times 3 times 7, or 210 ways. So again, make sure you understand the difference between these two types of problems whenever you are trying to simplify or find the solution for values where order matters, permutations, where order does not matter, combinations.